Good morning, good afternoon, and good evening. I'm Deepak Shankar, founder of Mirabilis Design. Mirabilis Design is exhibiting in booth D3 at the INCOSE International Conference in Detroit from June 25th to 29th. Mirabilis Design, as an introduction, is the only commercial provider of system modeling IP and simulation solutions for system architecture, exploration, and analysis. VisualSim expands the scope of model-based system design by providing the means to get accurate performance, power, and functional results from the simulation of traffic and use cases against the specification. Using the VisualSim environment, designers and researchers can create a prototype of the proposed architecture, map the behavior on this architecture, run a variety of configuration and task partitioning, and identify the optimal configuration. VisualSim architecture exploration generates insights on the architecture by evaluating the requirements against simulation results for timing, throughput, buffer occupancy, functional correctness, quality of service, power consumption, and failure analysis as well. The system analysis includes scheduler selection, system sizing, resource sharing, task distribution across compute resources, and low power management. Mirabilis Design has a committed university and research program. We provide the complete VisualSim software package, laboratory projects, application templates for over 150 applications, and a cloud version that can be accessed from anywhere at any time. When you consider an architecture, there are really three main areas. There's the communication, which is all the topologies and the networks. There's the compute and the scheduling. When you want to put a design together, you have to combine the three in different formats. There could be configuration formats, topology formats, mapping formats, different types. Some can be completely distributed and some can be completely shared. Now, the real question comes up is which architecture is better? In this case, is it architecture 1 or architecture 2? The right answer is it depends. And what does it depend on really? The application. The application is what determines which architecture is most suitable for your particular implementation. Now, let's take a complex system today. One of the areas of SysML and model-based system engineering is the mapping of applications on a compute platform. There are so many different ways to partition the tasks. There's AI accelerators, there's GPUs, there's processors, there's DSPs, microcontrollers, in-memory processing, and a host of others. Now, let us consider two applications. You can see one right up here and another one that will mysteriously pop up at the bottom. Now, we have an architecture here with two processors, and what we're going to try to do is map these against that architecture and try to understand what is going to happen in this particular system. So when I take the first application and I map it, you can see that there is a flow from task 1 to 4, and it goes across the IO, CPU, buses, DSP. So there's a flow of data, both there's a transfer and a compute that's happening. Now, when you look at this design, there's no problem because it's very easy for you to predict exactly what's going on in the design because there's really no contention, there's no concurrency, there is no, like overlap, things like that. But now let's consider a scenario where we add another application and we do a similar type of mapping. Now, when you look at this mapping, you start seeing there's a lot of overhead in all these different locations. This leads to a lot of contention. And now it becomes a lot more complex to really propose what is going to be the expected latency, what's going to be expected throughput. Are you going to be able to meet your timing deadlines? Without a simulation environment like VisualSim, it'll be really hard to predict the performance metrics. So how does VisualSim work? You start off with your requirements, you add your block diagram. Using the tool, you construct up a model. You run a variety of trade-off studies and architecture optimizations. And once you're done with that, you come up with an optimized architecture, be it for the system or be it for a semiconductor device. Now, This architecture can then have a high level of confidence to say, yes, this is going to work when you eventually deploy it in your particular system. And this is what we're really looking for, is to take it from concept to an optimized system. Now, one of the things that makes VisualSim unique is the ability to be able to work right across the product design cycle. So you can start with like a mission planning of a very, very large industrial system or a satellite or a network of constellations, to looking at the semiconductor, to looking at an integrated or a distributed system with a lot of boards and a lot of software and networks, and finally, to a completely networked system like data centers or edge devices connect data centers or cars connected to data centers. And with this, you would have a complete understanding of how your overall system is going to behave. We welcome you to INCOSE conference and to our booth at D3. Thank you.